So today we'll continue where we left off from our last session. In the last session, basically to summarize and recollect, we have seen in general what are the different phases involved in a statistical analysis. So first design phase, the second descriptive phase, third inferential statistics phase, and so now that being said, let's go into the furthermore into details of the statistical analysis, and we'll cover a few of the fundamental concepts today. Ever since, before we dwell into that, let's try and understand what's happening in the recent few years, etc. So ever since there's obviously the internet and digital boom had happened, there is a tremendous increase in the amount of data that normally the companies or enterprises store, and all of this data is normally structured under the big umbrella called big data. And under this big data, we have two main segments which are I felt which are important to cover, just to give you a definition of what these are. Broadly, you can categorize the big data into structured data and unstructured data. And before we jump into this, let's take a quick example of what these structured data and unstructured data, and to get a sense of what these things are. So this is a simple example of a doctor's appointment related prescription. Okay, let's say, so we have different fields the doctor is prescribing. On the first column, we have time of the appointment, symptoms that the patient doctor has observed, diagnosis, prescription, referral, and test. So, and how structured and unstructured data is in the same scenario can be seen as. So for example, in the unstructured data is just the text part, whatever the doctor has written, right? For example, for time, doctor has written earlier today, experienced chest pain, operation scheduled on Tuesday. So that is the unstructured format of denoting a time of a certain date, whereas in a structured format, it becomes a proper date format, which we are all familiar with while working on dashboards or developing any sort of analysis. Similarly, symptoms, if you see, doctor has given a very general text of explaining what a symptom is, whereas that will not be helpful for us if you want to make an analysis. It has to be structured in a way, hey, I know you have identified these symptoms, but give me in such a way where I can use it in analysis. So we can see that there is a certain number, some sort of thing, N24230. So that number is identified for that sort of pain and the second symptom. So there's some sort of, you can already see that the difference between unstructured and structured data, that normally on the structured side, it's just the everything is just represented in the form of a text or something, whereas on the structured side, it is more organized and identifiable by a certain idea or something like that. So this is a typical example, and the reason that we are I'm bringing up the structured data and unstructured data is most of the statistical analysis that we know or we studied from the our courses or whatever, they are applicable on structured data, but they are not on the unstructured data. So unstructured data, it needs to be converted first to structured data for any sort of analysis to be made on it. And it's as you can see from the example, that for us to convert the unstructured to structured, there's a lot of manual process that could be involved. But fortunately, these days, the technology like artificial intelligence and machine learning, that they have made some amount of progress in automating the process, but it's still not at a full extent. So to give you a quick example, like if you see, like ever since the social media came up, we have the data like the comments, reviews, etc. They're very quite popular, and they hold a lot of information, right? So, but they are just like they also come under unstructured data, just like the right column that we see. It's not easy to process what a person is trying to say, and And in order to be able to analyze that sort of data, there came a branch of studies called sentiment analysis, right? So what does it do? It takes into applications of NLP, natural language processing, and processes the text and categorizes that into, hey, what kind of sentiment that this review is passing. So there are a lot of techniques, other techniques as well, which are currently used to process unstructured data, analyze unstructured data. But for going forward, for our interest, we'll only focus on the structured data. So just to give you a broad definition or distinction between both structured and unstructured data. Structured data is basically, we can consider it as a highly specific and has a predefined format for each of the fields and etc. Whereas on the unstructured side, it's broadly just a text irrespective of what field that you're trying to look at, and it's not very well defined and distinguishable. So that is the case of let's see a few more differences between the structured data and unstructured data, and we'll try and proceed to further. Okay, the first main difference that you can see is the structured data will be expressed in the form of a proper rectangular table that which we are all familiar with, whereas on the unstructured data it is not, cannot be represented in that rectangular format. And moving on, all the images, audio files, video files, the text documents that people write, we can say articles or any of the, so there is a ton of data that will be present in that format. All of that will come under unstructured data, whereas in structured data we have a very defined numbers, dates, strings in a rectangular format. And of all the data that we normally have at the moment, we can it's considered that 80% of it is it's coming from the unstructured data, and 20% of it is coming from the structured data. Unstructured data requires more storage, whereas structured data it doesn't need much more storage. And the last point is more difficult to manage. So it's basically telling that unstructured data, all the traditional solutions or the statistical solutions that we have more techniques to study and analyze structured data, but we don't have more techniques and to study or analyze unstructured data. So so those are the broad differences between structured data and unstructured data. Now, that being said, it obviously makes sense since we are saying that, hey, we can only make statistical analysis or most traditional method of techniques or analysis on structured data. It makes sense to ask a question: what constitutes a structured data? How do we define or identify a structured data? So, and that brings us to which brings us to this topic or something that which we are all very familiar with from the very beginning, which is called data types. So these are normally called as elements of structured data. So wherever we can define the data in these elements, in these data types, it can be considered as a structured data. So I will not go through this, which is very basics. We have continuous data, we have discrete data, we have categorical, binary, and ordinal data. So there's just one point that I'll stress over here is the difference between ordinal data and nominal data. Most of you will know it, but the difference here is nominal data and ordinal data both are categorical data, but whereas in nominal data there is no significance to the order, whereas in ordinal data there is a significance to order. Let me just give you an example and cover that up. Let's take let's say your very general example that I normally use very often, that is the roll numbers in your respective colleges. Let's take a person with rule number 1 and take a person with rule number 100, right? And now just because they have 1 and 100, it doesn't tell us anything that one person is better or worse when compared to the other person in any aspect. It's just 1 and 100. There is no significance to the order 1 or 100. So that comes under nominal data. Whereas under the ordinal data, there is significance to that order. Let's say the typical example for this would be the ratings that you will give on maybe if anything, the food delivery or something. So you give 1 and you give 5. So there is a significance to the order. There's a meaning between 1 and 5. So that normally comes in the ordinal data. But apart from that, everything is same. Okay, and let's say yeah, okay, so since now you know that you have what a structured data is. Let's say that you have collected a structured data for statistical analysis. Okay, let's assume that now we are focusing only on structured. Let's assume that you have went through the design phase and you have got your structured data, a table, rectangular data, and you want to study it, take it forward to descriptive analytics and inferential statistics. Now, given you have a data, let's call it a data related to marks of students attained in a certain test. Okay, you can format in a neat structured format way. Now, how do you describe that data? That is our next phase, right? How do you describe this table of data? So then the question that will bring us to the concept, something called data distributions. So if you see the visualization on the top right, on the right side, we can see that on the x-axis we have number marks out of 20, and on the y-axis we have number of students. It's basically telling on each of those mark point how many students are did receive those number of points. And as you can see, once I plotted out all the students in the class, I'll get the frequency distribution. So data distribution is nothing but a frequency distribution of individual values in the data set. On each of those data points, what is the frequency, how many students are there. And as you can see, this sort of a distribution, the distribution which we are currently seeing is there's a specific name to it. It's called normal distribution. Distribution itself is a whole another topic. We'll come to the distributions at the right time, but for the time being, let's understand that this is a normal distribution. So the data which we have collected, marks of the students in a class, is following a certain distribution. So now that's well and good, but how does this distribution describe or give us a sense of what that data is representing? That brings us to the concept, or in fact, let me ask this question. So earlier we saw a typical normal distribution, and here we have 3 normal distributions. They're all of them are normal distributions. And how do we can visually see that here they're very different distributions, the green and red and the blue. But how do we what distinguishes each of these distributions from the other? And that brings us to the concept called measures of center and measure of variability. So first, let's talk about the measure of center of the distribution. So that is nothing but where this distribution has the center. So for example, obviously this, because of the symmetric nature of this particular type of distribution, the centermost peak where that particular value will be called as the center, and this particular 0 will be called as the center for distribution in red, and likewise. So that is one thing that distinguishes each of that separates each of those distributions. And the other measure that which we can use is measure for variation or range. So it's basically how much are each of these distributions are varying on the x-axis. So if you can see, the one in green, we have just a very less range when compared to one in red, and one in blue, which has the highest range, right? So these are the 2 types of measures which we can used to identify or distinguish between different data distributions. And we'll go a little detail into each of these things, but let's for the time being, we'll call the measure of the center, let's call it as mu, and the measure of the variation or range, let's call it as sigma square. So yeah, as you can see, the red one, mu is equal to 0, which is basically center is at 0, and the sigma square is 1. It's a measure of let's only try and understand the sigma square in relative terms for the time being. So for the red one, we can see that it has a range of 1, and blue one, which has a higher range than red, so it is about 4, and green one, which has a lower range than red one, so it's about 0.25. so these are the two metrics or measures that we can use to distinguish the data distributions: measure of center of the distribution and measure of variation or range of the distribution. Now okay, that being said, let's now try and focus on let's try and focus on the measures of center. We again, this is something that we are all very familiar with. I will not go through all of these things. So we have mean, median, and mode. Under the mean, we have various different variants: weighted mean and trimmed mean, etc. Normally, people call them statistics, estimates, and parameters based on the context in which they are trying to talk about. We'll get into them a little more in detail, but for the time being, let's just call them statistics. I don't have to explain these things to you. You already know these things very well, but let's just try and understand what measure of center, either a mean, median, or mode, which one to use at what time. So let's try and actually, let me pull up an Excel sheet. So okay, so here in the Excel sheet, I have some sample data of crime rates related to US in each of the state for every year. Okay, let's so for the time being, what I'll do is I'll just filter for 1 year to analyze the data for 1 year to look into that. Okay, so let me just take the latest year. Okay, and I have different fields here, but I don't be needing all of that. Let's just take maybe first 4 columns. So we have state field, we have year field, and what's the population for that particular state, and we have how many crime rates are reported in that particular year in that particular state related to some properties or etc. So let's take these 4 columns. Okay, so let's assume that this is the data that you have collected, the structured data, and we're trying to describe this data. Obviously, the ones that we saw just now as measure of center and measure of variance. Right now, let's try and focus on the measure of center. Try and identify what is the differences between mean, median, and mode. Okay, let's say I try and get the mean of the entire. We all know how to get that. So average, let me take this, right? So I got average about some 12 million. So it's basically trying to tell us that, hey, on an average average amount of population on any state that you might pick up is about 12 million population, right? That's what it means. And let me try and get the median as well before I explain the differences between them. Let's take the population. Okay, and median is coming about 4.4 million, 4.5 million or something like that. So that's well and good. Now let me just okay, I got the let me actually yeah, if you see these data points, okay, we got 12 million as our population, but one thing, if you observe and go through the data points, there is something that you will observe like this. Okay, there is a row called United States. Okay, and this is not a particular state which we thought we are trying to deal with. We thought each row is a state, but which is not actually. Here it's basically summarizing the total of all the population states. And since we considered this also into our mean calculation and median calculation, it might be affecting. So it's not what actually it is representing. We want at the state level, so we cannot include the aggregate value. So what I'll do is I'll try and actually sort this. Okay, and I will try and ignore this column, and I'll get the mean without that value. Okay, you can see that the mean has drastically fallen, right? So from 6 million we have reached to some from 12 million we have reached to some 6 million. Now let's try and look at the same for our new median. So it will be, sorry, yeah, median seems to have not changed so much. So earlier it was 4.4 million, now it was 4.3 million, which is pretty close, but it's not changed drastically as our mean. So this is a very interesting topic that normally people take into consideration, that whenever your data is filled with outliers, your mean is very much influenced by the outliers. So obviously we did United States by mistake here, but assume that, okay, even if we ignore United States, okay, let us but that explains the point that mean is is very much influenced by that particular single data point which we have included by mistake, but whereas median is not so much. Median is always trying to give you the an approximate center, not being too much influenced by the outliers, that those extreme values. So that is a very important concept in statistics. So let's say even if when we are looking at the states, okay, we can see that let's try and get the distribution of these, so we will understand the outliers a little more better. Let me change the words. So I've given the bin size as 1 million, and if you can see that, so what it's basically telling you here is, in each of this bin, so from 50.5 million to 1.5 million, how many states are there? So I have, in this particular range, I have 12 states, and likewise all the, so this is my data distribution. So it's not the same distribution that which we saw in earlier, the normal distribution, which has a perfect bell shape, but it's more of a semi normal distribution, only the one half of it, right? So you can see that, but most of the data, almost 80 to 90% of the data seems to have falling under this range, below this particular point on the x-axis, but whereas these few data points are on the extreme value. So we can it tells you that, hey, these points are very different from most of my data. So this is the definition of how you identify the outliers. So if some of the data falls very different or extreme to most of what your data is, you can consider them as outliers. So even though we have excluded the United States total and we have got a 6 million, that our data distribution is telling that, hey, there are still outliers in your data. We can consider like these, there are 2 states here, and there is 1 state here, and there is 1 state. There are 4 states which you can consider them as outliers and get a corrected mean. So let me try and again, it's actually a same concept. So let me go back to our PPT first, and yeah, it's the same concept actually. So we have mean, median, and mode. We have just saw how median is very less influenced by our outliers in the data, and whereas mean is highly influenced by outliers in data. And mode, which we are all very familiar with, I don't have to describe. Outlier, yeah, so that is something. After that, okay, let's try and see the distribution that which we got. Let me actually explain what something called a trimmed mean example. So we have something called trimmed mean. Let's go back to our Excel. Okay, so there's a function called mean. Okay, and what it does is it takes it will give you the average only, but what it takes into the account of the outliers based on your parameters that you specify. Let's say, for example, trim mean, I've given the same range and it's asking for the percentage. Let me give you 0.1 and explain what that 0.1 means. If you would see, my trimmed mean is now reduced. It has gone from 6.1 million to 5.2 million, right? So what's happening here is the 10%, the 0.1 is actually referring to 10% of the data, and what it's trying to do here is it will try and look up in the data distribution, okay, in the data range that you have given, and it will take the top 5% of the data which were maximum and bottom 5% of the data which were maximum. Both 5% constitute your 10%, and it will exclude those things. So it will exclude the top 2 values here and the bottom 2 values here, and for whatever the rest of the values, it will calculate the mean and it will give us this much. So it's a it's basically trying to make a mean a better term when you have a usable measure when you have outliers in the data. So you can normally people prefer median, but if you have to go for mean, you just have to go for the trimmed sort of mean, where you take into account of all the outliers.
Jagdish, a quick question. So as you use trimmed mean and you put that parameter close to, let's say, 0.45, then
Right.
then the trimmed mean will sort of tend towards median, right? Is that correct?
Right. So the idea was, yeah, we need to get. So it's not like it's tending towards a median. It's just that the median is representing a certain center value, which is more accurate than the mean that which we saw. And the moment we are excluding these outliers, the mean is also tending to that center, which is being represented by median. So so that's what it means.
And Jagdish, I also have one question. So for trimmed mean here, you gave parameter as 0.1, right? So top 5% and bottom 5% of data won't be considered for considering the mean.
Right.
So like what all things should be considered before giving that parameter value? So currently here you have given 0.1, like 10%. Is there any way based on like volume of data or something you have to decide and give that parameter?
First, you need to get a sense of how many outliers do you have on the top right. So if it's the case that there is only 1 or 2 outliers, like the example where we consider the United States total, it's only one. Let's assume that's if there's only one such data point, you can just go ahead and exclude. You don't need this trim mean and etc. It will unnecessarily disturb all the data. The reason is though we have here only the outliers are on the extreme side, which are positive x-axis, but on the lower side of the x-axis you cannot call these lower side as outliers in this particular case, because most of the data seems to be lying in that range as well. So it's not ideal to remove this data, but the trimmed mean, it functions in that way that it will take top and the bottom in the range. It will take basically whatever the percentage top and bottom. So normally you just have to manually identify or give a criteria which distinguishes your outliers and remove that. If you don't have a criteria, you have to come to a distribution and look for what are the outliers, and you have to eliminate them. Trimmed mean is just a if you know there is you can definitely eliminate certain amount of data on the top and bottom, you can go for it. There are lots of ways again. Okay, so let me just quickly go back to our presentation. Okay, so that is about mean and median, and mode is something that we all familiar with. Let's try and understand the distribution. So if you would recall the distribution that which we saw here, it's perfectly symmetrical about the center of the x-axis, and it's called normal distribution or bell-shaped distribution, bell curve distribution. Now, but the distribution that which we saw in the Excel sheet is not a normal distribution. It's kind of trending like this, right? It's starting and going down as we progress across x-axis. The one that represents similar to the distribution on the top. So these sort of distributions are called skew distributions, which are not basically symmetric on their center. So the skewness, whatever the metric that is represented to identify what type of skew it is. So the one on the top, it's called right skew distribution. The one on the left, it's called bottom, it's called left skew distribution, and it will basically try and identify basically how much deviation this particular distribution is having from a perfectly symmetrical distribution. Based on that deviation, it will try and identify the magnitude, and based on that magnitude, that skewness will be taken into account. If it's just slightly different from a normal distribution, the skewness will be less. If it's very highly asymmetrical and different from the perfect bell-shaped curve, the skewness will be high. So so these are two types of distributions: skewed distributions, right skewed and low bottom skewed. And in the example that which we saw, we tried to identify outliers and we eliminated them for the to get a better sense of understanding of the data. What is the mean and what is the correct mean and median? But oftentimes there will be also analysis where you're not interested in the rest of the data, but you're only interested in that outliers. So it's not always recommended, hey, the outliers are we have to ignore them all the time. So there is something called anomaly detection, where you only focus on outliers. You will forget about the rest of the data, but you will only focus on the outliers. For example, just to give you a practical example, think of a credit card fraud detection, right? So you have a credit card, you make transactions, you use it for years, right? And the credit card fraud detection, what it does is it will try and distinguish the very drastic or any suspicious activity in your credit card based on your past transaction. Let's say you have made all your transactions in a certain locality in a country, but for some reason, just in a week's time, this credit card transaction had been made in some other country somewhere else. Okay, and then it obviously brings us suspicion that, hey, this credit card might have been stolen or information might have been leaked. So that particular outlier of happening somewhere else to the rest of all the transactions that are happening in your locality might act as a trigger. So where that sort of thing, where outliers are only focused in anomaly detection, so that those analysis is also present. Let's try and conclude. So today we have just seen what a data distribution is and how do we describe a data given as structured data for us. And we have seen measures of center. We have seen a few examples. Let's try and see where to use each of these measures. Okay. Mode is a measure of center which can only be used on which will be mostly used on qualitative. So mode is like normally used when we are working on qualitative data, and mean should be used on quantitative data, the one that we have shown, but the distribution has to be perfect distribution. It shouldn't be like skewed distribution. The reason, if it's skewed, then there is outliers. You have to take outliers into account and adjust your mean accordingly. And median can be used on any distribution. Normally it will tend to represent the center, but when you have a skewed distribution, people try to go for a median. So those are that's all I had prepared for today, guys. If you have any questions, you can bring them in.
So there is one question about outliers. Generally, if the measure value, if it is much above average, only those values are considered as outlier, or even the values which are much below average are also considered?
No, it works in both ways. In the case that we saw in Excel, it just happened that we don't have any outliers on the bottom side, but it can have in both ways. The identification there should be if any point lies on either of the extremes, positive or negative, from the most of your data, you should consider them as outliers.
Okay. And one more question. So what all softwares or tools do you recommend to convert the unstructured data in structured format?
See, that is still something which I'm not very familiar with. I'm not so sure if there are any tools as such as well. But that is something that I may have to look into and come back.
Thanks, James.
Just one point. So while identifying outliers, the average has nothing to do with it. Okay, just if you just see the words which Jagadish used, right, those are the most important words. So he said, what are the values which are away from most of the data? So that is that most of the data or most of the distribution, that is the operating here. The average. So when you're trying to identify outliers, look at the distribution and see what lies outside of most of the distribution. The average has nothing to do with it by identifying outliers.
Right. Okay. I think that's it for today, guys.